Hello, and welcome back. This is a video of part two to go through these practice problems so that we can do these effectively. So let's go ahead and go through each of these. And what I want to do, you can leave this equation in its same form, or you can rewrite it with the log on the left side. Okay, it doesn't matter, but that's how either way. All right. So same thing. The 7 is my base. Okay. This value over here is not a 3 or an x. It should be a 3. Okay. And so 7 is my base. Okay. It wants to become the base. 3 is my exponent. The log drops off, and we get x is equal to 7 to the third power. Okay. And we can write that in an exponential form. And because, we can evaluate this, let's go ahead and do that. So 7 cubed is going to be 343. So we can say x is 343. Okay. I would accept both answers. All right. And that's all it wants us to do is to really to rewrite it like this. But if you can evaluate it, let's go ahead and evaluate it. All right, let's take a look at part B. Part B, let's rewrite that with log on the left side. So log base B of 25 is equal to 2. Okay, so B is my base, 2 is my exponent. The log drops off. So we get 25. I'm sorry. 25 is equal to B squared. Okay, and that's it. All right, that's all we're doing. Over here, 4 is my base, y is my exponent, so we get 26 is equal to 4 to the y power, and that's all we're doing. Okay, we're just going from log form to exponential form. Okay, now let's do the opposite. Let's go and put this into, write this into log form. All right, so what I'm going to do is I'm going to write log base 2 of x is equal to 5. Okay, remember that this value here is the exponent. Okay, and we're just doing everything we were doing before. Okay, all right, over on part B, we're going to write this as log base B of 27 is equal to 3. Now, I put a parenthesis around that. You don't have to do that, but a lot of times it does help to put a parenthesis around those just so that we can distinguish what's our base. Okay, now over here on this one, all right, we have e to the y equals 33. Now I'm going to write this as log base e of 33 is equal to y, okay? And that's the value. Now, because I have log base e, because e is that number, okay, I can write this as the natural log of 33 is equal to y. And this is what I would want you to do. I want you to make sure that if you have log base e that you're writing the natural log and not this stuff here, okay? Okay, let's take a look at the next one. The next one we want to evaluate. Okay, now when I evaluate these, what I want to do is this. I'm going to do log base 10 of 100, and I'm going to set that equal to x. Okay, now what I'm going to do here is I'm going to take this value 10, all right, put this into exponential form, all right, first. So I'm going to take 10, shove that underneath the x, the log drops off, so I got 100 is equal to 10 to the what power. So 10 to the what power gives me 100, and that value, x, is going to be 2. And that's how you evaluate these, okay? So the first things first is that you set this equal to a variable, all right, which is going to be your exponent, and then you have to figure out what your exponent is. And that requires just thinking, okay? All right, so now on this one, let's do log base 5 of 1 over 125, okay, is equal to x. Let's take that, put it into exponential form, so 5 to the x. So the log drops off, 1 over 125 is equal to 5 to the what power is equal to 1 over 125. Now, what we have to do is think, okay, what do I have, think about the graphs that we did the last time. If I plug in a positive number here for x, it's going to get really big, okay? But if I plug in a number that's smaller than 0, a negative number, that's going to give me 1 over 125. And the value that we're looking for is x is equal to negative 3. So we have to think about the concept of the graph in order for us to evaluate these logs, okay? So, and let's just think about it. If I take, we can always check 5 to the negative 3 is equal to 1 over 5 cubed. Well, 1 over 5 cubed is just 125, so we get 1 over 125. Okay, so this is our answer. All right. Okay, the next one, 36 to the what power gives me 6. And so let's do this. 36, let's rewrite this in exponential form, or with it, set it equal to x. So log base 36 of 6 is equal to x. So I'm going to take 36, make that my base, x is my exponent, and I get 6 is equal to 36 to the x power. Now on this one, it's a little bit weird, okay, because we're not going, 36 to the what power gives me a smaller number. That's not a fraction like we had over here. So on this one, what we have to think about is this concept of rational functions. Now remember that if I take 36 to the 1/2 power, that will give me 6. Remember that if I take something and raise it to the 1/2 power, I'm really just taking the square root of 36 equals 6, and 6 is equal to 6. So what I've concluded here is that x is equal to positive 1/2. Okay, that one's pretty tricky, okay, but just remember on how these work, okay? So, some number raised to a power, we get a smaller number, not a fraction, then our exponent has to be between 0 and 1, has to be 1/2, okay? All right, let's take a look at part D. Part D, let's rewrite this as log base 3 of the 7th root of 3, and that's going to equal x. Okay, so I have 3 to the what power gives me the 7th root of 3. So let's write that. The 7th root of 3 is equal to 3 to the x power. Now here's what I've got, okay? If I have the 7th root of 3, remember that's really, I'm just taking 3 to the 1/7 power, and that's equal to 3x. Now if my bases are the same, and we'll talk more about this when we're solving these equations, if my bases are the same, then I just set my exponents equal to each other, and so I get 1/7 is equal to x, and that's it, okay? All right, let's go ahead and take a look at the next page. Okay, so on the next page, we're still just evaluating these functions, okay, and these logs. So I'm going to do log base 9 of 9 is equal to x. So I'm going to take 9, make that my base, x is my exponent, the log drops off. So I've got 9 is equal to 9 to the x power. Now think about it, 9 to the what power gives me 9. And so that value of x would just be 1, okay? And we can check, all right? We can do 9 to the first power, does that give us 9? And that's true, okay? So we can always check, all right? Now let's do this. Let's do log base 8 of 1 is equal to x. So I'm going to do 8 to the what power, log drops off, so 1 is equal to 8 to the what power. Now any number raised to a power and I get 1, the value of x is going to be 0, okay? And so we get 1 is equal to 8 to the 0 power, 1 is equal to 1, and that's true, okay? All right, let's take a look at the next few. Now this one may look, these may look a little confusing, okay? But what I have here is I have, let's set this equal to x. So let's do log base 7 of 7 to the 8 power is equal to x. So take 7, make that my base, x is my exponent, my log drops off, so I get 7 to the 8 power is equal to 7 to the x. So remember, if your bases are the same, then you just set your exponents equal to each other, and so x is equal to 8, and that's what we're looking for. Okay, part B is a little bit weird. Okay. And the reason why it's weird is because I have a log within an exponential, okay? So remember that exponential, okay, exponential and logs have a relationship, okay? They are inverses of each other, all right? They are inverses. So, when you have a log, so when a log is in the exponent, okay, they cancel each other out, okay? When a log is in the exponent, they cancel each other out. All right, and so what you're left with, given this situation here, what you're left with is, and you have to make sure that your bases are the same, okay, but 3 to the log base 3 of 17 power, boom, that goes away. All you're left with then is 17. Okay, so if you remember that these are inverses of each other, then these kind of they undo itself, and you're just left with what's inside, which is 17. Okay, all right, let's take a look at the next part. Find the domain of f of x equals log base 4 of x minus 5. So when we're doing these, okay, when we're finding the domain of a log function, what we have to remember is the fact that, and let's just look at just a generic graph of a log function. Okay, so remember it's an inverse of an exponential function. Remember an exponential function looks like this, okay? And these are reflected over the line y equals x, all right? So you have your log function looks like this, okay? And here's the idea, okay? In my log function, let's just call this y equals log base 2 of x. Or no, sorry, this would be y equals 2 to the x. This one down here would be y equals log base 2 of x. Now remember what goes on here. Okay, remember the domain of my red function goes from negative infinity to positive infinity, but my range goes from 0 to infinity. Okay, when I'm talking about a log function, remember that my domain is restricted. My domain goes from 0 to infinity. Okay, and remember that my range goes from negative infinity to positive infinity. Remember, all we're doing is just switching my domain and ranges here because they're inverses of each other. When we have an inverse, we just switch x and y. So, based on this, what I know is that my value x, okay, x has to be greater than 0, okay? And that's what I'm concerned with is what goes in here. And because I can't plug in a negative number, okay? And remember why is because on the exponential, my x values are always positive, okay? Therefore, I'm sorry, my y values are always positive on my exponential function. Therefore, my x values are always going to be positive in my log function. So for me to find the domain of this function, all I want to do is take x minus 5, what's inside my log, set that greater than 0. I'm going to add 5 to both sides, and I get that x is greater than 5. And that's it. Okay. Now that's my answer in set builder notation. What I want to say is that I would go from 5 to positive infinity. Okay. And that's how we do those. But I wanted to make sure I went over this concept of how we get the domains and ranges, and the fact that whatever we plug into the log has to be positive. Okay, let's go ahead and skip this problem here. It's a little bit confusing. What I do want to do is talk about the domain of each of these functions. Now, same thing. Even if it's a natural log or a log, whatever's on the inside, 4 minus x, must be greater than 0. Okay, so now what I'm going to do is I'm going to add x to both sides. Okay, and so what I get is I get 4 is greater than x, okay? Or I can say that x is less than 4. Either way, those mean the same thing. And when I do that, okay, what I'm going to do is I'm going to go from negative infinity to positive 4, okay? And that's going to be my domain, okay? We could write it as any one of these three, okay? Preferably we write it in interval notation, okay? On this one, h of x is equal to the natural log of x squared. So what I have here is I want to take x squared and I want to set that greater than 0. Now here's the thing, is that when you square something, so when you square a number, it's always positive. Okay, so because that's always positive, okay, this statement will always be true. This is always true. Okay, therefore, my domain goes from negative infinity to positive infinity. And that's all we're looking for, okay? So that's it. Let's not worry about the word problem. Let's not worry about the problem on the next page. Let's just go ahead and move on to 4.3 once we've done all the homework and all that good stuff. So hope you enjoyed this video, and we'll see you in a bit. Thanks a lot. Bye.